Hola a todos, muy
Hello to
buenas tardes.
everybody. Good afternoon.
Nos encontramos en el panel Ciencia y
We are in
Tecnología
the
y su
panel of
aportación al
Science and
manejo
Technology and its contribution to preserving the
Se
environment.
encuentra con nosotros
We
nuestro
have the
director
presence
general
of our host for this week of environment, Jorge Rescala Perez, and the head of the
y el doctor
Mexican Science and Technology Council, Aldas Calderon. Thank you so much for being with us.
Agradezco la presencia de los
I want to
panelistas
say thank you to the panelists
todos
who are with us
expertos
today,
que nos ocupan.
all experts in this topic, and I cordially welcome each and every one of our
La
participants and
Semana
viewers.
Nacional del Medio
The
Ambiente
International Week on Environment is created to listen to national and international successful experiences that want to counter effect global warming through more than 50 different activities. We have lectures, workshops, and events such as this one. We are going to try together to find solutions that science and technology can offer us. Now we are going to listen to Bernal Almaraz Calderon, who is the director for the Mexican Council of Science and Technology, known as COMECI. This is for the state of Mexico. Thank you very much. Good afternoon to all the people who are with us today. I greet you from Valle de Bravo. We are doing an education activity to supervise some activities that have to do with environment in the technological higher studies of Valle de Bravo. We are very happy to greet all of you from here in this very interesting panel for today. I want to say thank you to the Ministry of Environment, Jorge Rescala, for inviting us and having the possibility of participating in this panel. Thank you so much, Mr. Secretary. I also greet Susana Libien and the distinguished panelists who will be sharing their knowledge today regarding the management and preservation of environmental services. For the government of the state of Guanajuato, understanding the challenge of our environment is a purpose that in COMECIT we want to address. That is why one of the actions that has been determined by our governor, Del Mazo, is to make environment a priority. That is how we have assigned in the first grants invitation in 2021 in the state of Mexico, grants for students in sustainable rural management in the Intercultural University of the state of Mexico and a master's degree in environmental services in the Higher Institute of Studies of Coacalco, as well as degrees of environmental engineering in the state of Mexico and in the degree of renewable energies in the Technological University of Tecabac. Likewise, when we talk about research, in COMECIT, we are directing the support for stays of research and PhD projects to better understand from a scientific perspective the environmental challenges of the state of Mexico. I want to underline some projects that are very original and the impact that they are going to have. One project is called nanocomposites of yactate titanium chains as a photocatalyst to reduce organic pollutants in wastewater. This is a project of Amin, and it's being done in the Politecnica of the Valle de Mexico. The other project is called Identification of Biological Pollutants that are putting at risk the health in potable water in the state of Mexico in the eastern area. Mayra Nicolas Garcia is in charge of this project in the Technological University of Nezahualcóyotl. In this university, we also have the work that is called Development and Consolidation of a Research Lab for Sustainability of the eastern part of the state of Mexico. This is developed by Ubaldo Casas Toriz. Likewise, there are many other projects and studies that we are backing up in COMECIT, and we have the study on the use of waste of the construction industry and the incorporation of new materials with green chemistry. This is developed by Alejandro Ramirez in the Mexiquense University of El Bicentenario. We can also talk about degradation of toxical gases in the presence of nanocatalysts and the application of the ferroelectrical materials to mitigate gases that pollute and that are coming from gas vehicles. Both these projects are developed by the University of Tecámac by Roberto Reséndiz and Gerardo Betancourt Cantera. Another element that we should underline in this research is one that is called thermoeconomical aspects in the generation of clean energy, cogeneration and combined cycles, developed by Carlos Guzmán Castillo in the Tecnológico de Estudios Superiores of Ecatepec. Likewise, we also have a project of COMECIT in environment that is called characterization of kinetics of a bioreactor of films that are thin to cultivate microalgae, also developed in Ecatepec by Elisa Garcia Cruz. And in a relevant way, I would like to underline the collaboration that we are having with the Ministry of Environment, especially with the State Institute of Climate Change. And we are supporting a research project that is developed by Erika Rivera Martinez for climate sustainability in urban areas following islands of heat in the state of Mexico. These projects talk about the interests that we have in the state government of the state of Mexico focused on the environment. As you can see, we have a very strong commitment to environment from the perspective of science and technology. With the leadership of Rescala, I am convinced that we will be able to continue on with these projects of further scope to find innovative solutions that are based on a scientific basis. I thank you so much for this opportunity to be able to talk with you, discuss with you, and talk about these projects that we are developing, and also listen to the experience of our distinguished panelists. Thank you so much for your attention.
Muchas gracias, doctor.
Thank you so much. Now we give the floor to Jorge Rescala Perez, Secretary of Environment of the State of Mexico, that is going to give his message and open this international panel. Mr. Secretary, the floor is yours. Thank you. Good afternoon, Mr. Panelists and all the participants. Thank you so much, Bernardo. Thank you for all the support to be able to have this panel on science and technology. For a few decades, many scientists and specialists had warned us that a pandemic could occur at any time based on experiences like the Ebola outbreak that we had in 2014. So we see that we are harming the planet due to the uncontrolled growth that we are having. However, in the last decade, we have come together in the point of no return of natural resources. So there are many international agreements signed, for example, the one of Paris and the SDGs of the Agenda 2030. However, there are fewer and fewer legitimate voices. These are not sufficient to be able to stop global warming. Nations such as China and the US are responsible for many of the emissions of pollutants into the planet. However, now it's urgent to realize that the biggest changes in humanity begin in the transformations that each and every human being does in their daily life. It seems that the pandemic has brought with it a change in our habits, making us cleaner. However, we also have to be aware of the fact that we have a unique opportunity so that in government or in any other organization, we can promote an environmental culture in each inhabitant. And that way we can have sustainable practices. Like Mario Molina stated, climate change is the most serious global problem that mankind is facing. And we cannot face it if human beings continue thinking that we are the center of the universe. It seems that in the coming months, we will overcome this pandemic. And then once again, we will focus on a lifestyle according to our new reality. In this stage, we have to act with a lot of responsibility based on the awareness that many years we have said that we are going to act in a different way. But the reality is that we have continued harming our environment. Maybe this is the last opportunity that we have as humanity. Climate change is here, and its consequences can be even more catastrophic than that suffered in the pandemic. Science and technology have helped humanity to improve their quality of life, to overcome hunger, and to have communication, and to reach places that we never imagined before. But more importantly is to overcome the challenge of the 21st century that is called climate change. And in this task, each and every citizen of the world share a responsibility that cannot be left for later. Thank you very much for your attention. So at 1:16 p.m. in Mexico City on June 16th, I declare the opening of this panel of science and technology in preserving the environment. I am convinced that with ideas and proposals that are proposed, we will continue building a planet that is stronger. Thank you so much for your attention. Thank you very much, Mr. Secretary. So let's begin with this panel. And out of respect of the time of the panelists, it's important to remember that you have 20 minutes for your presentation. And at the end of the presentation, we are going to have a Q&A session. So now let's listen to the presentation of Helena Saren. She is in charge of intelligent business, and she is going to be talking about the role of conversion of energy and in value and the development with low carbon emissions. Saren is the director of the program of Smart Energy Finland in Business Finland. This is an organization funded by government, and it offers a possibility for innovation activities, internationalization, investment, and tourism promotion. She has more than 25 years of experience in international business. She began with the development of business in Varsava, and she has a lot of experience in consulting and internationalization, funding, development of investments, and in the program of growth of energy. And recently, she was appointed the responsible party for Smart Energy Finland. It includes more than 100 enterprises in energy that generate energy, that have smart networks, batteries, as well as many others, and the economy of hydrogen. She studied engineering in Helsinki. And Helena, the floor is yours.
Yes, thank you. And you should now hear me and see me, and I put this on a presentation mode. Okay, thank you. And good afternoon to you, and good evening to at least some of the other panelists here in the Europe time zone. It's already 9 o'clock, almost 9:30 in the evening here in Helsinki region here. So it's a great pleasure to be here today. So within next 20 minutes, I'm going to have a brief introduction on this topic. And as I understood from Susanna's presentation, well, she introduced Business Finland, so I skip it very quickly, that one. But then I introduce briefly about our strongholds, how we do and walk the talk ourselves. And then I have a deep dive into various kinds of waste to energy and waste to value ecosystems and their pros and cons. And of course, I have to be very brief and pretty quickly go through the presentation, so we can have later on more in details discussions either with my colleagues there in Mexico City, or then organize a separate webinar or something. And here actually this week I actually changed a little bit of role within the Business Finland, therefore there are two positions there. So middle of this week we changed our way of operation. I'll have taken two missions into action and missions guided activities, and I'm leading there the zero carbon or low carbon development. So actually, well, anyway, it's about the same topic anyways. So not going to go through this as Susanna introduced what is Business Finland about. I try to put you there, I mean, a little bit hide you here from my screen. And where should I? Okay, now. Only one thing I would like to mention, that from our innovation funding point of view, last year we funded energy-related innovations with over 240 million euros. I mean, Finnish companies and research and organizations. And another topic is definitely there, that between 2006 and 2019, we have been funding with about 2 billion euros the low carbon development. And what we have seen very clearly is that in the beginning, it was more about certain technologies and solutions. But during the last years, it is more directed to larger scale ecosystems where companies jointly try to solve these vast challenges we are having. And this is a very good occasion what we are having here today, because the challenges we are facing on a global level are so huge that we definitely need one another, and we need competencies and experience from different parts of the world in order to create more sustainable future for our children. So this is most probably the most ambitious target in the world. So it has been decided that we are going to be carbon neutral by 2035 and carbon negative by 2050. And that means that all the sectors in the society have to be involved in this development. And when we're having a global look, so about 71% of global greenhouse gas emissions come from 3 sectors, which are energy, manufacturing, and then the third one is transportation. And it's pretty much the energy sector which enables the other 2 sectors to decarbonize themselves. And it is clear that also the energy sector is the driver almost in every country in this low carbon development. And in Finland, one example, we are phasing out of coal totally in our energy structure by 2029. And some cities have already done so. And most of the cities or the city-owned energy utilities are going to do it at around 2025, 2026. So pretty ambitious targets we do have. Just a brief glimpse from our point of view about the 3 cornerstones of Finland's energy-related expertise. So we're talking about climate neutral electrification, smart and flexible energy systems, and circular economy energy, which is more or less about the recycling the valuable molecules of especially hydrogen, nitrogen, and carbon. So hydrogen economy, power to X, and everything lands in that territory. And what I like in this picture, even though it's very busy, but it shows that all of these segments interact with one another. So that is one of my messages also here, that we should have a view on the holistic solutions, not to go on partial solutions, but having the total economy, the country, city, region, and look from that perspective, which would be the most optimal solution for the whole energy infrastructure. And there, this waste to energy and waste to value is definitely embedded there. Very briefly, our point of view, municipal solid waste to value is one of our strongholds, whether we're talking of large centralized solutions or smaller scale decentralized solutions. Bioenergy, definitely bread and butter of our economy, especially when we are talking about forest-based solutions. Advanced biofuels, nothing to compete with the food production, of course. efficiency, energy and material efficiency in power plants or in otherwise in process industries in generally, and more solutions coming into the picture in the circular economy. So it is more and more important that we utilize and convert the valuable contents of, for instance, side and waste streams into something valuable. And we definitely need to circulate our natural resources throughout all the value chains in the economy. And then saying that walk the talk. So like I mentioned earlier, we are very rapidly phasing out coal. And I don't know why this is here in between my picture. Okay, now. So this is at the moment the situation. So in 2020, so last year, renewables 51% of our electricity production, CO2 neutrality was 85% and domestic was 51%. And to my topic, over 99%, so almost 100% of our municipal solid waste in the total country are either turned into energy or converted and recycled into some other material. So in this, when we're talking about waste to energy and waste to value, these are some market drivers in this respect. And I would like to pinpoint here a couple of issues very relevant in many countries. So definitely the present and existing landfills are overcrowded, or they are also that kind of old-fashioned way, so they are causing lots of environmental hazards and environmental problems. Then the existing landfills cause a lot of harming impact on the global warming. So definitely when we are talking about methane emissions, they are actually very bad for us to try to do the climate change mitigation activities. And definitely various kind of health and environmental impacts, which are obviously negative, are caused by the landfills. And then what is quite often the challenge is definitely the funding, because when we are talking about the waste to energy and waste to value issues, like you see in some of my next slides, we are talking about quite large investments. And in order to increase and enhance the investments to take place, there has to be that kind of regulatory environment and legislation, and also that kind of financial structure that the investment can be economically sound. Because like I have sometimes said, that no one will invest if they can't see any income revenues coming in, income streams coming in. So that is one of the most challenging features in the waste to energy and waste to value segment presently, because it's in the end quite often it's the customers anyways who paid one way or another, and so forth. So then when we are talking about the municipal solid waste more into details and about the environmental impacts, so definitely, like mentioned, it's the greenhouse gas emissions, then the inorganic waste and different kind of chemical compounds and so forth. They produce the leachate, which on its turn pollutes soil and groundwater if the groundings of the landfills have not been done properly and the way they should be done in order to gather the leachate, not to let it go down there to the groundwater. And then different kind of pests and so forth are definitely living around the landfills, and likewise some kind of bacteria and microbes growth area. And then there are also other streams of waste which should be treated with a different pattern, different paths mentioned here, like hazardous waste, also hospital waste, and different kind of e-waste. So there are different tracks for those. And at this presentation, I'm not going to go through of these, and I have to say that about the hazardous waste and hospital waste quite often depends on each country's legislation. So what is required and what kind of waste can be treated, for instance, in the waste to energy plant, and which cannot be. Okay, I have a couple of slides which are very, very busy. And then on the right-hand side, there are the triangle where there's a cost efficiency, energy efficiency, and waste reduction. And when we are talking about the waste to value dilemma, it's a trade-off between these three. So if the solution reduces a lot of waste quantity, so it's generally the most expensive, well, obviously. And then if we are having the very cost efficient solutions, then it does not reduce the amount of waste that much as it could, and it does not generate that much power either. And the most energy efficient solutions cost also then much more. And then on the right-hand side, there is SWOT analysis. In each case, I'm going to pinpoint just one or two issues out of that because we don't have time. And then on the right-hand side, there on the top, there are some calculations. And after a couple of examples, there are the basics, how these calculations have been done. So there is a interest rate, there is gate fees, there is price of electricity, and so forth. So giving the indications what kind of amounts we are talking about. So firstly, pretty much we are talking about the landfills, so no waste to value in this case. And but when building a standard, the landfill that fits in with the present standards, they definitely have to be taking care of the soil contamination protection, and also the groundwater pollution protection, and prevent landfill gases emitting, and taking care of also health and safety issues. If we are having a look on the opportunities in the SWOT, so definitely that landfills as such, they can be as a future fuel source. So at the time when waste to energy or waste to value plants are built, these existing landfills can be used as a fuel source for them. Then if you go climb up the ladders in the value chain, so the next is focusing on the cost efficiency, and so then we are talking about pretty much the waste fuel production, SRF, EDF, or so forth, to replace, for instance, coal in the cement kilns or power generation. But in this case, the organic waste is not treated further. This is an example, obviously. And in this case, the waste quantity could be reduced by 25% plus. And here, what we are talking about, the strength is that this is pretty robust solution and low capex and fast to deliver. So that kind of pros is within this kind of a solution. And then when we go further, so talking about the waste to value solution, and then having more and more waste to be reduced. And here, incineration of inorganic waste and recycling the recyclables, but then composting the organic waste. So in this case, that kind of a solution. So the weakness in this one is that definitely a large area is required. And when we are talking about the highly populated areas, for instance, like in Mexico, it is sometimes quite often to find such large areas to put all the, for instance, the composting facilities there. But like in all cases, there are opportunities and there are strongholds also in these ones. Like an strength is that methane reduction is 100%, but it's done in this case by composting. And then when we are going even further about going to 90% plus of waste quantity reduced, so then we add on to the previous previous example, the biogas production. And this is, of course, more sophisticated solution, but what we see definitely more capex, significant capex is needed. And when we are talking about in this example, 1,600 tons per day capacity, it would be close to $200 million investment of such ecosystem. And even going higher in the waste quantity reduction, getting closer to 100. So then we add on more of these circular economy solutions, as an example, adding the fertilizer production and recovering metals from the combustion ashes, and they can be also wastewater treatment plants. And obviously internal synergies, so using excess heat and that kind of solutions in this ecosystem. And then capex is obviously climbing higher, $200 million plus, with the examples and the pricing we had in these examples. But obviously, when we are thinking about sustainable future, this covers pretty much all the waste streams and is very efficient from waste reduction point of view. And I believe that we are heading towards this kind of a solution. So we need to recycle more. We need to have our circular economy more into place. But in many cases, we have to take the baby steps to go there. So meaning that in some cases, we need to have more robust systems, start from somewhere, learn by doing, getting public acceptance for that one, and then gradually climb up the ladders. And also from the investment point, from the risk point of view and so forth, it's sometimes it's easier. And we can start also for the smaller scale units. And these are the financial assumptions where the calculations are based on, and obviously we don't have time and I'm not going to go through, but you get the materials so you can have a look on them later. And then very important issue that in different parts of the world, we have come up with a question of the public acceptance. And when we are talking about these modern waste to value and waste to energy ecosystems, it is not the same thing as sometimes public thinks that when landfills are on fire or they are burning waste, it is emitting a huge amount of smoke and everything. So that is definitely not the case. And but for this public acceptance, lots of things needs to be done. And here in this table, sorry, they are pretty small in size, the numbers. There are the figures about the emission levels in the EU directive in both MSV, and it's compared in this one with coal. And all, like in all cases in our companies and in Finland and in the European Union, we definitely follow and are much below of these levels which are stated in the directive. So coming pretty much to the end is that with the waste to value ecosystems, one of the key local benefits, I could say, that it can provide, if done wisely and involving local communities, so new kind of jobs can be created which are then also healthier and also a little bit better paid than, for instance, manually picking up the trash or so forth. So definitely can provide huge employment opportunities. And then also new business opportunities up and downstreams for various kinds of operators. And this is definitely an ecosystem where are lots of operators in that one are creating cooperation. And then it is increasing the locality and using of local fuel sources, and definitely this can be added, for instance, with other excess biomaterials or so forth. Obvious health and environmental benefits, and in many countries we are running out of, for instance, clean groundwater. So with these actions, we keep the existing groundwater healthy and not polluting them. And definitely doing a lot for the future from the climate change mitigation point of view. And then also when we are talking about the areas and cities which want to attract competent people, educated people, knowledgeable people, that kind of a green city, climate change pioneer images, cities are there as the forerunners and can attract more of this kind of people to live in the area. So and then the last one is about the carbon credit schemes, which should be utilized in order to help from their financial point of view. So at this point, I think I have used my time and I'll end my presentation here. And awfully sorry, but I cannot stay for the rest of the seminar for obvious reasons.
Muchas gracias, Helena.
Thank you very much, Helena.
Yeah, thank you, and sorry for taking too much time. I didn't see the timer when I showed my from my own computer. Sorry about that one.
No problem, no te preocupes.
Don't worry.
Gracias.
Everything is okay. Thank you. Thank you for such an interesting
A
presentation.
continuación, cederemos el uso de la palabra
Next, we
a
pass the
Valerie
floor
Graf,
to
de la
Valerie
Universidad
Graf from the University of
de
Graf,
Alemania.
Bochum in Germany, and to Jose Alvear from the University of SOAI in Ecuador, with the presentation of his monitoring and training in the Amazon area. Valerie Groh is actually a scientist in the University of Germany. She studied a master's and a PhD about the economic drivers to achieve environmental change. Her field of specialty has to do with the risk of disasters and the coupling of sociological elements with cross-disciplinary elements such as observation and science of information, including surveillance of Earth to protect biodiversity in the world and local populations. Before she became part of the RUHR, she was also a scientific collaborator of the University of Punta. Together with two partners from Ecuador, she started the energy project, C for Amazonian. The initiative has the object of including the native communities in the recollection of data and cross-disciplinary sketches so that they are part of the road to sustainability. Jose Jaraviar is the coordinator of science and energy of the ASUA University in Ecuador, but he is also an expert in strategic planning of Corporación Eléctrica in Ecuador, where they analyze and assess the energy resources and create solar generation projects. He studied also a PhD on the evaluation of sustainability on electricity for the Amazon indigenous communities using solar energy. He has more than 12 years of national and international experience in renewable energy. He participated in the development of the first wind parks in Ecuador and the first solar ship Galapagos. His first interest is to integrate sustainable energy systems, geoscience, and research cross-disciplinary methods. The floor is all yours.
Thank you very much for the invitation. I'm going to share my screen. So I'm going to talk together with Jose about the project SE for Amazonian. It was a joint idea that developed and where we finally got the opportunity to get funding from the World Bank to actually conduct this project. So the project is on sustainable energy for Amazonian and about participatory mapping to support sustainable energy for all in the Amazon region. So I'm going to talk about the project and I hope you can see my slides. So we're talking about indigenous communities. They are living very deep in the Ecuadorian rainforest. So they are not connected to basic services. They are kind of left behind and they are not connected to the energy grid most of the time. So renewable energy is actually a solution for them. So what we did in the project was to address SDG 7, access to clean energy for all, but of course also other SDGs were addressed like SDG 1, 12, 15. There is the core line on leave no one behind. So we want to reach out to those that should be addressed and also include them. So we wanted to facilitate the access to renewable energies for the indigenous communities by using an interdisciplinary approach. Participatory mapping, remote sensing, GIS, but also socioeconomic information. And the idea was also to transfer it to other countries of the Amazonian. So this is our research area, the Ecuadorian Amazon, and we're talking about communities that are marginalized, often live in high poverty. So here you see data from nighttime light. So what you can see is that actually in the Amazon, we have no light at night, so no electricity most of the time. These indigenous communities are mostly left behind from the national electrification plans. They have a lack to electricity and rather use inefficient sources of electricity. So like batteries and fuel. And sometimes when, for example, they use batteries and they are empty, they throw them into the environment. And of course, this causes ecosystem damage as well. So when we look at the distribution of electric sources, so the area without electricity, we can clearly see the high percentages here in the Ecuadorian Amazon. And also those who are connected to the grid, actually, also not that many. So why now using Earth observation for this project? So for us, the question was, where are these communities? How dispersed are they? And how big are these communities? So usually you don't have a lot of knowledge about this. So what we did was, this is our SE for Amazonian approach. We used satellite imagery and processed these images. We developed land use and land cover change map to understand what's happening in the region. And then we added socioeconomic information. So from example, from the census data, but census data does not really give us information about the indigenous communities variables actually. So this is a more detailed data set we would need. So this is why we added the participatory mapping survey. So we had indigenous people that were actually trained to use an app. And with this app, they conducted a survey. So they collected the information and also helped us to collect information to validate our satellite imagery classifications. And with all this information together, we could develop a renewable energy provision plan. So we had, of course, in addition, workshops and conferences. So we started with a kickoff where we discussed why, for example, rural electrification plans until now mostly fail, and what are the priorities in the Ecuadorian Amazon, and how to electrify the isolated communities. We did this together with stakeholders, so we brought indigenous and stakeholders to the table and had quite lively discussions in these workshops. Capacity building was one of the core issues in our project. So we did capacity building workshops, especially the team in Ecuador. We trained the local technicians so they could use the app. And it was important to involve the whole community. So as soon as a community member says that she does not want to be part of the project, the community was taken out to respect actually the privacy and the data of these communities. So these were the surveys. We used an app called GeoFarmer, and we trained the local technicians how to use it so that they could actually collect information on income, energy sources, numbers of batteries. So all this kind of information we need to actually provide such a rural electrification plan. And in addition, they also made pictures around the location where they stood. This helped us, for example, when we use algorithms to classify our satellite images, to see if it is really true what we actually classified. So this also was a training. So the local technicians came to the Universidad San Francisco de Quito in Quito, Ecuador, where they were trained by the Geocentro, actually. So in Quito, they learned how to use this application, how to collect the data before they actually left to their communities. And these were some of the community maps. So they also made some maps just on paper, and we could see that it actually very well responded to what we saw in the images. So all this data was combined. And then we used the remote sensing images. So you see here on the left, a high resolution image by SkySat, so you can see much more detail than by the Landsat image with 30-meter resolution, for example. Each pixel is 30-meter resolution. So with the information from the survey, we could actually get information on the population density to know how many people do live in a pixel we observed and how densely populated is this pixel. In total, within only 3 months, the local technicians could do a survey in 58 communities and 775 households. That's quite a high number compared to what we would do when we would just go to the Amazon by ourselves. So this made much more sense. Then we used a remote sensing-based index, which is called the Tesselled Cap Wetness Index. And here is a comparison of this index with high-resolution images. And you see that it correlated quite well with what we saw in the images linked to what we actually had on the ground with the survey information. So our final model, we had our population density information, but to have it until 2030 and not only until today, so think about sustainability, we modeled. So we used the images we had before to know the energy demand by or the settlement development by 2030. Then we had our tiers, our electricity needs from the survey. We combined it in a spatially explicit projected energy demand model to know if a community needs a solar standalone, a solar mini grid, or if the community should be connected to the grid. And with this, I hand over to José.
Ok, buenos días con todos. Muchas gracias, Valerie. Bueno, continúo aquí para explicarles el modelo.
How the model work to detailed. Here you can see a summary of the energy that is being consumed by the communities. Most of them, as you can see, are contaminating sources such as the batteries that they use or gasoline that they also use. And all these energy, the intention was that the project could identify which communities were using what, where are they located, and how can we swap the energy they use for solar or clean energy. Here we have important information, and the question is, the amount of energy being consumed by the indigenous community. Here we have some statistics. For example, in Brazil, we have information that it goes from 2 to 3.46 kilowatts per month. In Ecuador, 12. So we did a very deep analysis of the real demand at the communities with this participating mapping and the geofarm use. So this energy allowed us to have an idea of which would be the most appropriate system and size needed for the community or for each community. Here, we are showing the transformation of the map that was presented by Valerie on population, how many people live in each pixel. Now we have to change that information into energy. So according to the number of households, we can determine how much energy they will be using based upon the information that we presented to you before. So here we have an example to detail with the conversion. The colors that you see in the screen, for example, red, orange, is where we have high demand. That means that the households are very close together, or we have a larger population. The ones that are green or lighter green are the ones that are more dispersed with lower numbers of population. This is important to determine which technology would be most appropriate. In our next slide, here we took into account the recommendations that were given by the World Bank. The World Bank has great information on how to plan different type of energy systems for rural areas. Next, please. As you can see here, we have energy, we have density, and the question that comes next is, how are we going to connect them? With the grid that we already have, just extending it to them, which could represent a logistic problem, besides that it could cause deforestation because we have to attack the forest, or do we use decentralized renewable energy such as solar energy? So we analyze, for example, the distance, how far is it from the grid, the demand, number of clients, demographic information, and the complexity of the land. Next, please. And here we have a summary, actually an example on how our maps look. Here we have, in a very economic and fast manner, a planning model for rural electrification in the Amazonian. Green represents the areas in which we have to use the grid, and red are those areas in which we have to use our technology. Next, please. The systems that we are talking about that are not grid are individual solar systems. This is a typical system of a solar home system in Shuas, one of the indigenous communities. You can see the elements. We have a solar panel as high as possible next to the household, and then the equipment that controls the energy, the solar regulator, the inverter, and the lead acid battery that we need. Next, please. Next slide, please. Another option that was analyzed was mini grids. When the households are close together, the most economic solution is to concentrate the generation and then distribute the energy with a mini grid with cables, a very, very small grid that will help us distributing the energy among the households. Next, please. The GIS model for rural electrification took also economic variables into account. How much money do we need in order to take solar systems? So we did a very deep research and we identified costs for the installment of individual solar systems, the one that I have just showed. Most of the cost is in the equipment, but there is an important component, it's transportation and installation, because the Amazonian is a very far away place, and sometimes we even need air means of transportation to do our installations. Here we also analyze the solar mini grid cost. How much would it cost? And we identified, of course, the equipment as well as installation. And it's actually more or less the same relationship, but this, remember, is for communities that have a larger number of population. And here we have the final result. I have seen, this is a Zoom presentation of the river that I show you. Around the river, we have communities without electricity, and this is the map that could be used by those making decisions, the engineers and international cooperation on the amount of investment that we need to bring energy to these communities. The ones in red are the houses in which we need more investment to bring energy to them. And the energy has been designed to meet the needs of the community that we found out because of the community survey that we carried out. So here we are looking at the summary of the electrification plan. We have the electrification, the total investment for the total plan. We have a map with which we can make decisions in an easier manner, but also the community gets to know how the electrification will be done. Sometimes they don't even know. I want to highlight that many of these maps were made by the technicians of the community that were part of the project and trained in the project. And this is the same map, but it's a close up. So the community can say, okay, in my community, it looks that it's better from the economical and technical point of view to use individual solar systems per household. Or in the areas that you see with red, well, we are suggesting a mini grid. Now I will turn the microphone back to Valerie. She will continue with the presentation on the last phases of the project.
Okay, so as Jose just mentioned, important was also at all times to involve the indigenous community. So that meant that they also understood what we actually did. So we trained them how to do the model by themselves, so how to analyze satellite imagery, how to use the data they collected. So they also understood how was this data used. And just to give you an outlook, in the end, so actually towards the end of our project, the pandemic happened. So we had to arrange it a little bit to stay in contact with the indigenous communities, which actually also worked via Zoom. You can see one of the images, which is not too long ago, actually, where we handed over the rural electrification plans to Amazon GISnet. So Amazon GISnet, the community of local technicians we worked with. We want to promote the electrification of the isolated communities in a rapid, accurate, and affordable way. And I think we managed quite well here. We prompt the production use of electricity and increase the capacities of the local population. So that was really an important step here for us, capacity building. So at all times involve the indigenous, but also really invest here in this trust building aspect. Transfer our approach also to other countries in Latin America, Africa, Asia. We are in contact with Bolivia and Colombia to also check how SE4Amazonian can be implemented there. We want to test the transferability also beyond electricity in the remote areas. So think about the collection of data, about this really dense good data set where it was only possible by involving those that should be addressed. We created a research group, Siena, which is on renewable energy science, together with UDA and the University of Bochum, where we also work on the Sustainable Energy for Amazonian Phase 2 now. And also we do research for access to modern technology for cooking in the Amazon. CC Amor is another initiative we wanted to go further with, looking into cooking stoves and renewable cooking sources here in the Amazon. And with this, I would like to thank you, or we would like to thank you for your attention and also give you the access to our website as SE4Amazonia, where you can also get much more information. Thank you very much.
Muchas gracias
Thank you very
a
much.
ambos ponentes.
I want to say thank you to both our speakers
Para la presentación
for the presentation of iTree to see the environmental services. We now give the floor to Stephanie Fabiola Lopez Loses. She is an advisor in forest services in the U.S. She is a biologist. She studied in the Autonomous University of Mexico. She has a master's degree in forest sciences, and she has a specialization in urban development. Since 2009, she has worked on various research projects and services that have to do with urban forests and the National Institute of Forest Research and Agriculture. She has participated in training for methodologies of diagnosis of green areas, inventories of urban areas. She also collaborated in the adaptation of iTree Eco with programs of training the forest services of the U.S. And she is working as a consultant to offer training and technical assistance in the design and implementation of urban trees with the program iTree Eco. So the floor is yours.
Hola, un gusto. Voy a compartir
Hello,
mi
it's a
pantalla.
great pleasure to be here with you. I'm now going to share my screen. Thank you very much for the invitation as well.
Vamos a hablar un poquito acerca de
We are going to talk about the benefits
en las ciudades,
that we have from trees in cities and how this can be very useful to better manage our resources.
Primero quisiera hablarles
First of all, I want to talk about what is iTree.
conjunto de herramientas
And it's a toolbox developed by the Forest Services of the U.S. jointly with other companies, David experts, and other institutions that are focusing on improving urban forest. So we could say that iTree is the science of forest services at the reach of our users. Likewise, the idea of having these tools is to make it easier to manage our urban forests, to have more sustainable and resilient cities. That is the vision that the Forest Service has for the development of these tools. What you see on the screen in red squares are those that we can use in Mexico. What I'm trying to say is that some have already been applied internationally, like Canopy or the database that allows us to integrate data to be able to use the iTree application in other cities. And very soon, we will be working on launching MyTree. This is an app that allows you to quantify your ecosystem services. So this is a user-friendly app, and the idea is for people who do not know about trees can calculate the benefits that we get from them. What is iTree Canopy? I'm going to talk briefly about this tool. These are tools that we can use in Mexico. What it does is that it quantifies the tree coverage and other types of coverages that we can find in the city. We have an area defined here. And what this tool does is that it selects random places, random spots, and we assign to those spots shown in the tool. And that way we can know if it's a tree or it's a permeable surface or some kind of other coverage. And with this, we can estimate how many services this tree coverage offers us. We can quantify it through this tool. For example, it also allows us to analyze the coverage throughout time, and that way we can compare images of different years, of previous years, to be able to see if it has increased or decreased talking about coverage of trees. Likewise, in this quantification of the coverage, this tool also allows us to have a quantification of the benefits given by the trees. And what's important here is that we have a statistical precision here. For example, we can know carbon catching and atmospheric numbers. But it's worth mentioning that this information is based on what we have registered in generation of services in the trees, for example, in the US. So the information provided by Canopy is an approximation of what we could have regarding the benefits from the trees. Now I'm going to talk about iTree Echo. This is the most complete tool of this interface of these groups of programs. And this tool allows us to characterize the structure of the urban forest, the characteristics it has, and we can also have an economic approximation of this. This is a free program, so that means that any person can use this program. And the way this tool works is that we enter our information, for example, how many trees we have. There is information regarding species of trees in the database, and it also has information on climate and pollutants, and it also has information on Mexico. So this way, we can say which city we're in, what we're working on, and we can talk about altitude and all the different characteristics. And the tool can quantify the structure of the urban forest, the species that exist there, and how much carbon they catch, and how many atmospheric pollutants are around, because we want to, of course, see how it can clean our air. What is the amount of rainfall and the emission of volatile organic compounds and economic approximation? And also for these three first components, you can have a prognosis to see what results we would have in the coming 10 to 20 years. So, like I was saying, we integrate the information from the trees, and the first thing we do is calculate the biomass and foliage of the trees. And jointly with the climate and pollution information, we can quantify the ecosystemic services, the bio emissions, and based on this quantification, you can make an estimate of the economic approximation. This is not magic. How can it be possible that we can make these calculations? Well, thanks to research developed since the 90s on behalf of researchers of the Forest Services of the US and other institutions. They took on the task of understanding how the structure of the trees had an effect on its benefits. So they developed research, for example, one emblematic research project in Chicago where they began to quantify the benefits that the trees offered. And likewise, they developed the U40 model. And in the beginning, it was quantifying, for example, carbon catching and reduction of pollutants. And this model became more and more sophisticated, and we integrated new technologies, new models, until we came up to what we know today as iTree. And basically for these estimates, we use different algorithms and models that include rainfall, contaminants, equations of biomass, volume, and other allometric models. Likewise, the tool is integrated with new traits and functions with the information that is collected from users. So we could say that it still has a backup of research, of the research centers of the David Institute and Forest Center for Sciences. And what they do is they continue on with the research, they continue backing it up. And so now I want to talk about some of the advantages of this tool. Like I was saying, it's completely free. It is translated into Spanish. It's based on scientific research. And something very important is that it's using demographics on pollutants and local climate. So we are not using the information of the US or Australia. We are using the demographics of Mexico in various cities of Mexico. And it has various manuals and guides that make its use much easier. And it also has different ways so that we can work with these tools. This means that we can have a data registry in different formats, field formats, or also with the use of the interface that we have on mobile devices, and then you can index our information later on. Another advantage that we have is that you can use it at different scales. You can get results in different levels. This means that I can quantify how much carbon is stored in a certain area or a certain zone of my area of study or my whole area of study. So I can have these calculations made for me. And it's continuously being improved. They continue on adding more and more functions. And another very important part of the integrated information is that it allows me to understand the trees and its species, structure, dimension, and also what density my trees have. I can also know how many benefits are being offered in this area, how we can assess these benefits, and this allows me to have a strategic management of my trees. Obviously, the information that has highest precision is structure because it's the first one, and then based on structure, you quantify the ecosystemic services, and then based on these services, you can determine the economic value it has. I'm not saying it's not precise, it's just this is the order of precision it follows. And in the structure, we have the most precise information and the economic value the lowest. Now, its application, it's being internationally used in the countries you can see in this first row of countries, and it's being applied at a countrywide level. And on this map, we can also see how in other countries in the world, they are beginning to use it, not countrywide, but yes, they are integrating some cities. And like I was saying, fortunately, we have been able to integrate various cities of Mexico into this tool. For example, we had a project where we were able to add information of atmospheric, climate, and demographic contamination of 33 cities, the 33 most important cities of Mexico, maps, elevation, to get the tool to work. And we also added information on the different species that we have in the urban woods of these cities. So that is how we were able to have an ample use of this application in the country. And we can continue on adding more and more cities through iTree database. Now I want to talk about how we are using it in Mexico, what we can do. And we basically believe that this tool can be quite useful to manage our trees, to obtain resources, to promote their preservation and improvement, and to improve and promote environmental responsibility. I'm going to talk about a case in the municipality of Colima. We worked there jointly with IPCO, an NGO, and with employees of the city hall and volunteers to carry out the inventory of trees in this municipality. We began with training on how to use the tool, how to make an inventory. We helped them in the design. And what we did basically was to categorize the green areas based on their surface. And in medium and large ones, we used strategic random sampling, and in smaller green areas, we did it with conglomerates. And this is how we were able to measure lots and conglomerates. With this tool, we were able to have an estimation for all the green areas of the municipality. So this is the information that we had with the different lots. We have 400 square meters for the case of this sample. And in the case of the smaller green areas, what we did is that we randomly chose urban areas, and those that were chosen were censused. So based on this information, we were able to record 154 tree species in these green areas. We estimated that we have approximately 21,000 trees in these green areas, and that the green areas that are medium and large have a higher density of trees compared to the smaller ones. So this allows us to make decisions. For example, if we want to focus on reforesting, we know that we have more available space in smaller green areas compared to the medium and large ones. Something that's also important is that we quantified the benefits. Here you can see the numbers when we talk about reducing pollutants in the air and the atmosphere and capture of carbon. So the benefits came up to almost 4 million pesos. This is the yearly contribution of the trees in these green areas. And also we carried out an analysis of services generation in each area of the city. And what we observed is that the green areas in the north and northeastern parts were offering us a higher number of services. And we're talking about generation of services per unit of surface. And it turns out that in these areas over here, it's where you have people with higher incomes compared to the ones that are over here in the center part or eastern part. We also identified species with a good potential of generating ecological services. For example, we have the parota, that's what we call it. And even though these trees only represent 6.62% of the population, they are contributing 15% of storage and 8%, or they avoid 8.11% of counter dripping that these trees do for us. So it gives us more compared to what other trees do, other species of trees. And with all of this information that we analyzed, we developed the management plan of the trees for the city of Colima. And I also want to show you that this is not the only example that we have. For example, in the state of Mexico, we have been developing management plans with the iTree tool, and they implemented it in the Metropolitan Park Bicentenario of Toluca. Now it's being implemented in Metepec. We have some cases of using this tool in Mexico City and Puebla. And for example, in the case of Mexico City, they're doing it in the Chapultepec woods, and they are creating their inventory through this tool. Also in Tuxtla, They have carried out an inventory of various parks that they have, and they are also working with different management programs with Fernando. In Mérida, they have also developed materials and manuals or plans that recognize green infrastructure for the city. And in the case of Guadalajara, we have the urban network of woods, and they have also been using the iTree tool, and it's also been useful in Ciudad Juárez, in the Planning Institute of this city, in León, in Monterrey. There are some initiatives that are using this tool aside from these. So this is just an example of the uses that are given to you, these in various parts of Mexico. So in conclusion, we can see that an iTree Eco project can tell us what we have in structure, species, benefits, what's the value of what these trees are giving us, what can we do, strategies. It allows us to define improvement strategies of our urban woods and increase the benefits that they offer us. And also, if we establish these types of projects with various associations, we can integrate our community, the associations, government, and citizens in protecting our woods. And also what we can do is try to sustain these instruments of public policies to back up the public policies management. That way they can better manage our urban woods. So basically, that's what this tool offers us, or it's the framework so we can carry out our improvements. So in conclusion, we believe that iTree is an amazing alternative to assess and value our urban woods. Thank you very much, Stephanie Fabiola, for your intervention.
Okay, so now
We are going to talk about the telematics application in detecting forest fires in protected areas. This is going to be presented by Pedro Flores Marquez. He studied biology in the Autonomous University of Guadalajara. He has a master's degree in management in public administration of the Instituto Politécnico Nacional AC. In his professional career, he has been able to work in the 3 levels of government in the areas of social development and agricultural development. Inside the state of Mexico, he was the specialized technical secretary, and he was also subdelegate of rural development and agricultural development, and he was also a regional delegate for forest in Valle de Bravo. In the federal government, he was the national manager of forest plantations. He was also in the forest commission known as CONAFOR, and he represented the focal point in the tropical woods in 2017. In CONAFOR, he was also the manager in the state of Mexico. He is a founder of the Association of Professionals of Biological Sciences of the state of Mexico. Currently, he is the head of the Coordination of Ecological Preservation of the Ministry of Environment of the state of Mexico. Pedro, the floor is yours. Thank you very much. I'm going to share my screen now. Can you see my screen now? Can you just use presentation mode, please? Thank you very much. I want to greet our Minister of Environment, Mr. Rescala, Dr. Almaraz, who is the Director of COMECIT, and also I want to greet all my colleagues in this panel and all the people who through the platforms and social networks are listening and watching these presentations of the week on environment. I want to share my experience in the implementation of this project that's called Environmental Monitoring of Telematics System. This is for the protection and preservation of protected natural areas within the state of Mexico. First of all, I want you to know that the state of Mexico, which is in the central part of Mexico, has a total surface of 2.2 million hectares. This represents 1.1% of the national land or territory. We have the highest amount of natural protected areas according to national decrees, and they add up to 89. And jointly, they add up to a surface of 985,000 hectares. This represents almost 43% of the state territory. This means that 44% of our areas are protected in the state of Mexico. Of these 89 natural protected areas, 75 have a state decree, and the remaining 14 have a federal decree that protects them. An important column of our green infrastructure in the metropolitan area of the Mexican Valley, and that offers ecosystem services to the population, are the natural protected areas. Here in the map, we can see the location of some of the natural areas that are emblematic and that are located in the metropolitan area of the Valley of Mexico. And we can see 5 state parks that preserve natural ecosystems and a natural heritage. However, there is a lot of pressure on behalf of the urban areas. These natural protected areas are so important. We must protect them and preserve them to benefit the population and to have a better quality of life for our people. For example, there we can see Sierra de Guadalupe. This is a state park that's surrounded by 4 municipalities of the state of Mexico, and also it has part of the land of Mexico City. In this natural protected area, there are 4.3 million inhabitants that live around this protected area. So you can imagine the demographic pressure we have. And also the protected areas, we have Tepoztlán, Cerro Gordo, Sierra Hermosa, Patlachique, and in total, these add up to more than 20,000 hectares of soils that are being preserved. Right now, the urban areas host 55% of the world population, according to UN data. And they think that this number will grow up to 86% by 2050. In the case of our country, where we have a current population of 126 million inhabitants, it's estimated that in the coming decades, a large amount of the demographic growth will be towards urban areas. This means that by 2030, 83% of the national population will be concentrated in cities. However, for the specific case of the state of Mexico, with a current population of 16.9, almost 17 million inhabitants, 17% are already living in these urban areas. We have the metropolitan area of the Valley of Mexico with 21.8 million inhabitants that are smoking the population of Mexico City. So this means that this represents very important environmental challenges. We have, for example, the management of solid waste. In the state of Mexico, currently, on a daily basis, we are generating 17,000 tons of solid waste. And with the 9,000 tons that Mexico City generates, we have 26,000 tons of solid waste being created on a daily basis. Another important challenge is the quality of air. To have green areas in good amounts is very important, and we must adapt to climate change. We have to collect water in drip-offs, and another very important aspect, which is the topic that we are going to be talking about, which is the preservation of the ecosystems and their biodiversity. If we speak about Mexico as a whole, we have the highest amount of forest fires. However, if we talk about the surfaces affected, last year we were 9th nationally. This means that although we have many fires because of the characteristics of our state, we also have the capacity and the infrastructure to prevent and combat these phenomena. Fires impact the natural areas the most, as well as the forest areas generally speaking. And it's quite frequent that in these metropolitan areas of the Valley of Mexico, because of the pressure of high concentration and population and the activities that take place on behalf of mankind. We know that all of these are factors that degrade and that affect our nature, they affect our ecosystems, and they affect our biodiversity.
Likewise, it also impacts the quality of air because of the emission of particles into the atmosphere, the infiltration into water as we lose land, and generally speaking, human infrastructure, especially in the areas that we say that we have high demographics. And therefore, as a consequence, the quality of life of the inhabitants is impacted. In order to face forest fires, the authorities usually deploy resources and infrastructure and equipment. They also have staff to keep into control. And for most important events, it is necessary to put all the efforts together, the 3 levels of government and other associations. In order to strengthen these efforts, to reduce damages, we have to use all the alternatives at hand available, among which the use of technology. On behalf of the government of the state of Mexico, through the Ministry of the Environment, we developed the implementation of the telematic system for environmental monitoring that is dedicated especially for forest fires. As we can see in this system, we have this control center for the safekeeping of the equipment. We also have different cameras that have reach, and we also have kits to receive the information for the prevention of these phenomena. We also have the screen panels and the communication system. It's quite a complete system that helps us for this end. What's the purpose of this system? Well, the first one is to address forest fires in these protective areas and also in the territory that is next to Mexico, trying to reduce the impact on the ecosystems and to reduce the emission of contaminants. So from this center, we can visualize forest fires, and in a very quick manner, we can carry out the actions for the fighting and control. With this, we optimize the work and the resources among all the participating areas within the government of the state of Mexico, and also with the coordination with the municipal governments and other areas of attention, including the associations of volunteers. So let's look at the system, how it has been implemented. The process started in 2008. But before that, we created a technical project, a technical draft that had to be submitted in order to obtain the budget and the funds. It's actually a trust. With this trust, we support the programs and the projects in the megalopolis, and we received the authorization once the project had been approved. There was an initial amount in order to start with the development, about 2.5 million pesos. And with that money, for the first stage, we were going to install 7 cameras. Those are the ones that you see with the green circles. And for 2010 is when the cameras were installed. When the monitoring center started working, and it was located in the Sierra de Guadalupe State Park, which is within the Coahualco municipality. So we're talking about 7 analogic cameras, and 3 of them were in the Sierra de Guadalupe, 2 close to Tepoztlán, and 1 in the Patlachique, and another one at Cerro Gordo. By 2019, and as a result of the partnership agreement between several of the municipalities, actually they signed the agreement in 2012. And another trust is created for the protection of the Sierra de Guadalupe State Park. And the way it worked was very good. The municipal governments gave funds to protect this area, and with the funds of the trust for the preservation of Sierra de Guadalupe, we were able to install 2 additional cameras at the Sierra de Guadalupe State Park. So now we had 9 cameras in total. By 2016, once again, presenting projects with the trust for the preservation of the Sierra de Guadalupe State Park, for the improvement of the telematics system. We invested again with funds of the trust, about 2 million pesos. So it was possible to include 5 more cameras. So by 2016, we had 14 cameras placed in new areas, 4 in the Sierra de Guadalupe and 1 in the Tepoztlán Sierra or range. But now we're working about HD equipment, and we actually replaced the analogic cameras that we had before, which increased the quality of our view. Then by 2021, in February, also with funds from the trust, we approved a new project for the extension of the coverage of the telematic project. So 3 more cameras were included, and this is how we are. We have 17 cameras right now, as you can see them on my slide. So what's the coverage range that this telematic system has in each one of the protected areas? For the case of Sierra de Tepoztlán State Park, the one on the screen, the visual coverage with this system is currently of 48%. This as a result of the view received from 3 cameras, one in Huehuetoca, the other one in Tepoztlán, and actually 2 more in Tepoztlán. For the Cerro Gordo State Park, currently we have a coverage of 36% because we only have 1 camera that is currently providing us views of this protected area, and it is located at Teotihuacan municipality. For the Sierra de Platachicle State Park, we have only 1 camera, and we have a 19% coverage of the whole area. Sierra Hermosa, which is next to where the new airport is being built for Mexico City, the Felipe Ángeles one. The state park of Sierra Hermosa, even though we do not have cameras inside it, we support ourselves with the cameras from Sierra de Guadalupe Park. We can see that far. And we've been able to have a 25% coverage. And the last one, and as I have already said, it is surrounded by human communities around the Guadalupe Range. Currently, we have 12 cameras, and as of now, we have 92% coverage. Here, the purpose of my slide is to show the different percentages of coverage that we have in each one of the protected areas. So currently, the telematic system covers 52% of total protected areas. Most of these areas can be actually visualized. We also need to say that the monitoring system can actually support up to 32 cameras. So let me show you how it works here. The red circles are current cameras. And the extended project for 100% coverage for the other 5 protected areas implies that we need to install 15 more cameras. So we're trying to find a way to achieve this possibility so that we have 100% coverage. These new cameras will also be deployed in a strategic manner. 1 more in Sierra de Guadalupe, 4 in Tepoztlán, 4 in Patlachique, 4 in Cerro Gordo, and 2 in Sierra Hermosa. This is the behavior protocol that we have, or the performance protocol. This is a fire that started in January 21 in Sierra de Guadalupe State Park. As soon as the smoke is detected by the monitoring center, the brigades that are closest to the area are notified so that they can do the first fight. Then we follow and guide other brigades so that we can see what's the behavior of the fire, and with a complete fight, we can control and extinguish the fire. This is the work that was done. It was 49 minutes. But we had immediate response, and that is why we were able to do it so quickly. Why is this system a strategic tool? Well, because the use of this technology will allow us to have a very precise location of the fire. It would also allow us to have good coordination with all the fighting units, and because we can tell them about the roads, about the accesses, etc. And we can also have a fighting logistic that will allow us to analyze the progress, the request of further support, and the coordination among all the participating institutions. It is important to say that the use of this technology is not going to stop the fires. However, the detection and the fighting on time will maybe help us in reducing the impact into the ecosystem the preservation of the environmental systems, and the reduction, of course, of the contamination problems and all the impact in the infrastructure of the cities. For the Sierra de Guadalupe State Park that has 12 cameras already installed. We already talked about 92% coverage. Nowadays, 100% of fires are detected with this system, and that shows the level of efficiency of our system. As we have increased and extended the system, we can see how the reduction of events is shown, because we have been able to fight small fires quickly, and our efficiency index increases, as well as the use of human resources and equipment is more efficient. But what's most important, we are actually reducing the impact into the biological systems, the biodiversity, and the impact in the infrastructure. So besides the monitoring and detection of forest fires, which is the main goal of our system, inside the Sierra de Guadalupe State Park, this technology has also helped us in other activities, such as the prompt detection of activities that do not go in accordance to the area. For example, when people try to use the land for other purposes or to dump trash. And we have also been able to use this system for the rescue of missing people or accidents happening in the park. The purpose of my slide is that sometimes we have clear days in our atmosphere and we can actually see everything, but there are other times in which we don't. But with the cameras, we can see how far they go. For example, we can see the Popocatépetl, we can see the Iztaccíhuatl, and we can see the Toluca mountain as well. Now, taking into account the development plan for the state of Mexico, and in close coordination with the sustainable goals, the implementation of this type of technologies, it's important because it provides important benefits, social benefits, environmental benefits, and economic benefits. We have an improvement of our air, we reduce contamination, we protect the floor and water infiltration, and we also help, socially speaking, in reducing the insecurity. We improve the quality of life and the health of the inhabitants, especially those that are around these protected areas. And with respect to the economic benefits, we are giving better use to our resources, financial resources and human resources, and we also reduce the impact in our urban infrastructure. I have nothing else to say, but thank you for your attention and to encourage you to come to the Sierra de Guadalupe State Park. That's where we have our monitoring center. You're welcome to visit so that you can see it with your own eyes. And then you can also receive more information on it. But these are the tools that the State of Mexico government is using to face the problem of forest fires and its impact in the ecosystems and biodiversity. Thank you very much for your attention. Thank you, Professor. Now we pass the floor to Miguel Mayorga, founding member of Green Fluidics. He has a physics degree by the Puebla University. He has a master's from the Metropolitan University and a PhD in science by the same university. He's been a teacher of universities in the north of Texas, Brussels, and the Autonomous University in Mexico and in the state of Mexico. He is a member of the Physical and Chemical Society, the American Association for the Advancement of Science. He's published 45 papers in international journals about physics, statistics, optics, neuroscience, and others. He's the creator and he has received several acknowledgements, the Green Test Challenge and the Bon Ambience Project, as he participates in companies with clean energy. He has developed several technological projects with the MMX GTC002 MMC standard. He is co-founder of 2 startups and environmental science, among which Green Fluidics. They've been awarded as the 15 more important young people in the creation of this smart bio panel. They received this acknowledgement for being also part of the 30 most important enterprises. And he's also participated in different presentations, in different conferences, for example, in Canada in 2019. The floor is all yours. Thank you very much for the invitation. I am very excited to be here. And now I'm going to speak in English.
The value proposal of green fluidics and nanobiotechnological startup that tries to integrate sustainability solutions that could work in space in microgravity
Que
conditions
podría funcionar en condiciones de microgravedad
in the Earth. So,
con un gran impacto a la Tierra.
in particular, as was mentioned
De manera particular, y como ya se señaló en presentaciones anteriores, definitivamente contamos con una estrategia sostenible para tener este tipo de diseños con los que podemos controlar diferentes tipos de flujos.
work with biomass and to produce in one of our inventions a proposal for sustainable generation of biomass and clean energy. Then we have a mix of materials, nanomaterials, and metamaterials with a combination of green chemistry, sustainable, and scalability. Then one of our research materials concerns with cement when we can integrate natural fibers in order to have a mitigation of environmental products in buildings. And in addition, one of the tools that we are working on concerns with the EPD system for designing new building materials. And for instance, for some waste from industry, in this case, pineapple, we have designed an insulation panel that is used for a more efficiency of energy in buildings. And then these environmental declarations are very important to have data for sustainability indexes. Then we have applied for different designs, and in addition, additionally, in concern with metamaterials, we have designed some comfort, sound of comfort for buildings and for monitoring some microorganisms with ultrasound. Then this permits to have some data of microorganisms in water, for instance. Then, in addition, using waste materials from mining, for instance, then we have obtained some nanoparticles with a great heat conduction in water, and then the different properties in photoluminescence, bioimage, and mainly for nanofluids with great heat conductivity. And then with young students from biotechnology mainly and engineering, and we created a startup where we call it green fluidics, because we describe all the flows in our designs in a greener manner. And then the proposal concerns that this project was born here in Toluca, Mexico, and 3 years ago, and certainly we try to bring biotechnology closer to space in order to achieve a better quality of life on Earth. And certainly in this moment, mainly the young people that is in the team is in his 20s. And then, for instance, one of the problems that we are working on is to improve more thermally efficient buildings to the transition to sustainable cities. And then the important thing is to mitigate carbon footprint, and with environmental certifications for buildings. And then in addition to have a greater wellness for the users. And then one of our designs concerns in multi-purpose systems that can absorb CO2 from microalgae, because we have a particular optimization of architecture flows in our bioreactor, and then generate oxygen. In addition, in the gray part in this triangle, we have a concentration of solar radiation with optical lens, and then with a mixing of one part of photovoltaic parts in addition with a thermoelectric part, and with a flow of cooling of nanofluids, we have an efficient manner to conversion of solar radiation in electricity. And in the green part, in the small triangles, the greener that we are looking at that center, we have the circulation and formation of microalgae, and then we have a generation of electricity, a measurement of CO2, and a dry biomass. In this case, the microalgae can be used for food industry, for instance, or for precision agricultural precision for different systems like aquaponics, for instance, or vertical farming in cities, because the gray water, it can be used with a substrate of microalgae, and then we have a mitigation of waste of energy, but in addition of reuse of water. Then it is one of the important parts of the data for the environmental product declarations of this product. And then from the different SDGs, then and in the circular economy, we can see how we can use from carbon waste and nanofluids in the first part, in the production of this design. In the manufacturing process, we have used the minimum part of electronic parts of the system, and then it works for a better infrastructure in in some of the proposals of smart cities. And in addition, the second use of rainwater and the absorption of CO2 permits in with the managing of the data to improve the system. With the difference for the usual photovoltaics, in this we can have some improvements for the microalgae, so it evolves in time, and then the managing of the data permits to introduce different improvements in the new generation of nanofluids in order to have a better efficiency of the system. And then in addition, certainly it can act like in the climate action, and is an affordable and clean energy device. And certainly the different applications that we are working on, and the prototype is in the proof with windows, walls, and skylighters, and then and certainly we have different evolution of from the manual manufacturing to the scalability right now, in order to have a more industrial production for the market launch. And then certainly in the case of green buildings, for instance, market, there are different credits that are or green stamps for residential designs, green designs. And then this is a business B2B model. And then certainly the another part is the monitoring in cities, because it correlates all the data of the environment, and then the data with a tool of artificial intelligence means that making decisions for some variations in weather, for instance, and then this is a good detection for some possible variations in weather, and certainly with it improves the analysis of data for climate. And then in the case of buildings, it increased the value of properties because of the environmental certifications, and then promotes, as I mentioned, the wellness and health inside because of the production of oxygen, and in addition to the electricity generation and carbon footprint reduction and some energy savings, we have another different proposals that are in the market in the world. And then in this aspect, we have some awards for instance, this is one of the 100 solutions to climate change that we received in Vancouver in 2019, and the patent was evaluated in MIT in order to see the performance, and certainly right now we have participated in some contests in Berlin and Australia, for instance. And then an additional part that we are working on is that the system permits to improve some management in the biomass, in particular in the microalgae. Then our research and the developer and innovation goals include some design solutions that include the hydrogen production, because from microalgae, because some experiments that we have designed that includes the photolysis and we are working on in an optimized constructal design for a microplant for hydrogen. And in addition, with some photoactivation, we can have a regulation, optogenetic regulation of microalgae in order to have another manner to produce hydrogen. And the life cycle assessment that that is a tool in the system is automated. Then with another kind of physical-chemical experiments that with, for instance, for using volatilization, then that permits to have a better manner for a product declaration, environmental product declaration for the production of hydrogen. Then finally, this is our contact. So we are very pleased to collaborate with not only with Secretaría del Medio Ambiente from the State of Mexico, but in addition, all the partners that are in this meeting. Muchas gracias. Thanks a lot.
Muchas gracias a nuestros ponentes. Nos quedamos con algunas,
Thank you very much to all our speakers. I have some phrases from each speaker. Science and technology is the most important binomial to accomplish an additional binomial that will allow us to preserve life on our planet, which is development and sustainability. In this pandemic, we have learned that science and technology is used to preserve our species. Irene says that to be able to be neutral in carbon, the economy has to be global and the solutions also have to be global. Valerie said that without the support of vulnerable communities, development opportunities are not available to them. Fabiola says that to be able to fight against climate change, it's very important to take care of our urban forests, and her tool would allow us to participate in carbon markets. Pedro says that the importance of the use of technology to take care of our forests are our new safeguards in our factories of oxygen and water, which are our natural protected areas. And Miguel gives us an ample explanation that dreams come true and that the application of technology in the improvement of quality of life is possible. So now we are going to ask one question to each participant only because of time constraints. So let's begin with Fabiola and Jose, since Helena left the meeting. For Fabiola and Jose, the question is, which have been the main challenges working with communities? And do you consider that this experience can be applicable in the state of Mexico? In advance, thank you for your answers.
Ok, tal vez empiezo yo, luego le doy la palabra a Valerie.
I will begin and then I will give the floor to Valerie. The challenge of working with indigenous populations was quite large, especially because you have to create trust. And these are communities that are isolated, and history has shown that we have exploitation of resources. We have had non-participative processes. So the project worked closely in building this trust, and we were able to accomplish it. And this is how they implemented this project. They developed the model, and we had the success that we had in the project. And with no doubt, I think that this can be applied in different areas. We still have millions of people that don't have energy, and remote sensors cover the whole planet. And the application of GeoFarmer is an application that can be loaded on a cell phone. Valerie, would you like to add something?
I think the most important part was mentioned about the trust building, but another thing that also comes to my mind is about sensitivity of data and protecting the rights of the indigenous, because when we worked with them, sometimes we really needed transparency. We needed to exchange at all times. That was for us being located in Germany, looking at the satellite imagery, but exchanging with our colleagues in Ecuador and the indigenous, knowing what could harm them. Sometimes they don't know by themselves. So if we, for example, use these images, show where they are, what can harm them, to what extent. So this needed to be exchanged with all members of the project at all times. And this is something also for the future when we transfer it to other countries, that securing the rights of the indigenous and being an exchange is one of the important things. And also language, not talking about Spanish as a language, but using the words they really use and understand for the things that should be implemented. Thank you.
Muchas gracias.
Thank you very much. We also have a question for Fabiola. What are the areas of opportunities that iTreat Eco has, and up to what point do you visualize its development? Well, regarding areas of opportunity, what we saw is that we can apply the tools at different scales. So this means that you can have a very local application where we can use it maybe with purposes of citizen awareness or environmental education, where we can work with a small school or with the people of the area, all the way to a scope of applying it to municipal scope of regions, where we can develop it with a planned project under a methodology of sampling, with a methodology with certain statistical preciseness, to be able to quantify the benefits and be able to develop management plans. It can be at the level of a park, a municipality, or a whole region. And I think that it's quite useful, because in one way or another, it allows us to understand the conditions, but also quantify the value and socialize these benefits that urban forests offer us. And this also helps us to have a more comprehensive approach. And we want to make sure that we all participate in protecting our green areas, not just government, also citizens. These are some of the applications and strengths that I think the tool can have. Thank you very much. For Pedro Flores, considering the advantages of the use of this technology to detect fires in naturally protected areas, and to have a similar system in other areas of the state of Mexico or other regions, do you consider that through this system, it would be necessary to be able to counterattack the issue of forest fires? I think that the use of this technology is just one more tool of a part of a comprehensive plan to combat forest fires in the state of Mexico. And they strengthen our material and human resources to be able to face cases of forest fires. And like I said, in the case of the state of Mexico, due to various factors, it's quite complex. However, we can do this through close collaboration with all the agencies that have the capability to combat fires. And in the case of our entity, we do it through a unique command force that is headed by the state government of Mexico. Likewise, to be able to strengthen this aspect, also, aside from the use of these technologies, we have different state forest programs such as paying for forest services that promote the preservation of ecosystems through the execution of prevention tasks like lines, ditches, materials, etc. And this is done directly by the beneficiaries of these social programs. And the owners of these areas are the ones that do it, small landowners, etc. The use of technology is hugely important, of course, but another important aspect is to continue promoting an environmental culture and continue growing in our awareness among the population and preserving our ecosystems and protecting the environment at large. In this International Week on Environment, we are working on this awareness to create this awareness to be able to value our natural protected areas, both rural and urban, and be able to protect them once they are valued. And another important aspect, of course, has to do with the coordination of all the work among the different authorities and the organizations of the civil society, and of course, the always very important support of all the environmental educators that advocate this. So yes, it is a very important tool. Yes, we can use it in other natural protected areas. For example, in those of the Valley of Mexico, it has helped us to be much more efficient in the use of our human and material resources in favor of the main goal that we have, which is to preserve our ecosystems and their biodiversity. Thank you very much. We have one more question for Miguel. What would be the application of biotechnology in public works? Well, biotechnology would be the responsible use of biodiversity. So in public works, what we would do is that we would integrate biomass, which is a way of not only coexisting and cohabitating with new technology of the responsible use of natural wealth. For example, in the metamaterials that I mentioned, you can have bamboo columns, and these bamboo columns can also mitigate noise of traffic. For example, if you're close to a hospital, and they can be arranged in such a way that you can see through them. Obviously, we're talking about agroecology include in this public work, but on the other hand, in the census of micro labs that are automated to be able to detect some toxins in public works and that are also preventive. So there are various types of instruments that can be used in public works, in water management, energy management, and that can be decentralized. So in that sense, among what I mentioned, we have to consider incorporating some other biotechnologies in construction projects. So in that perspective, you mitigate the whole chain of value in the production of materials in the construction industry and in emissions. And on the other hand, the fact that once they are incorporated in infrastructure, they allow you to mitigate risks. Nanobiotechnology incorporated in materials of infrastructure, urban infrastructure, this would mitigate risks and it would contribute to better health, I would say. Thank you very much for your answers. Thank you to all our speakers. To be able to close this panel, we are going to have the final comments on behalf of Jorge Rescala, who is the Minister of Environment of the State of Mexico. The floor is yours, Mr. Minister. Thank you. I just want to say thank you to all the panelists, Valerie, Gra, Elena, Jose, Stephanie, Jorge, and Miguel. Thank you all so much. All your topics are so important and they give us tools to preserve and improve our environment. I also want to say thank you to the 250 people that listen to us through the Semana page and also through the Facebook and YouTube and Twitter page of the Week of Environment. And we have all these people participating in our virtual activities. Thank you all so much. This panel has been recorded as part of the International Environment Week. And I want to invite you also to the next panels that we are going to have on culture and environment for tomorrow and on Friday at 10 a.m. Youth activism in the preservation of environment, and also at 12:30, gender equality in preserving the environment. Once again, thank you all so much and have an amazing afternoon. Thank you, Mr. Minister. Good afternoon to all of you. And this is how we conclude this panel.